November 24, 1944, Tokyo, Japan. Major Yoshio Nakamura tapped the intelligence report against his desk at the Imperial Japanese Army Air Force headquarters, his lips curling into something between a smile and a sneer. "Look at this," Nakamura said, sliding the document across the polished wood. "The Americans believe their new bomber will decide the war." Captain Hiroshi Tanaka leaned forward, scanning the technical specifications with practiced eyes, then laughed sharply. 35,000 feet maximum altitude. Our Ki-84s can reach 38,000. Their bomber is a target, nothing more. Lieutenant Colonel Saburo Watanabe, chief intelligence analyst for the Tokyo defense sector, set down his teacup with deliberate care. "The reports from our agents in China suggest we should not underestimate their production capacity, Major. The numbers are concerning." But Nakamura waved him off dismissively, his confidence unshaken by the cautious words. "Production means nothing without performance, Colonel. We destroyed their B-17s at a ratio of 6-1 over Germany. At Rabaul, we shot down 12 B-24s in a single engagement and lost only 2 fighters. Over the Philippines, our pilots achieved kills at 8-1 against their so-called liberators." The mathematics were undeniable. Japanese fighters held air superiority at altitude, Japanese pilots possessed superior training and combat experience, and Japanese tactics had proven devastatingly effective against American heavy bombers. What Nakamura didn't know, what none of them could have known as they reviewed intelligence reports in that sterile headquarters conference room, was that the Boeing B-29 Superfortress would destroy Japanese air defenses within 8 months. The numbers would become catastrophic. American fighters and bombers would achieve kill ratios exceeding 20-1. American factories would produce 3,970 B-29s, while Japan's entire heavy bomber production totaled 91 aircraft across all types. Japanese pilot losses would exceed 10,000 dead with no possibility of replacement. The confident laughter in that Tokyo headquarters would become history's most expensive miscalculation, measured in 2.6 million Japanese military dead and the atomic annihilation of 2 cities. Major Nakamura had earned his arrogance through blood and victory. He had shot down 17 American aircraft personally, including 4 B-24 Liberators over Truk Lagoon in February 1944. His squadron had destroyed 43 American bombers in 8 months with the loss of only 6 pilots, a kill ratio that seemed to prove Japanese superiority beyond question. Nakamura flew the Nakajima Ki-84 Hate, which the Americans called Frank, a fighter that could reach 427 miles per hour and climb to 38,000 feet, specifications that exceeded every American bomber's performance envelope according to every intelligence assessment. The aircraft mounted 2 20mm cannons and 2 12.7 machine guns, firepower sufficient to cripple any 4-engine bomber with a single passing attack. Japanese aviation engineers had designed the Ki-84 specifically to intercept high-altitude bombers, incorporating every lesson learned from 3 years of Pacific combat. At altitude, the Japanese fighter could outclimb, outrun, and outmaneuver anything the Americans had previously deployed. The mathematics seemed irrefutable. At Yokosuka Air Arsenal, Captain Tanaka reviewed recent combat reports with mounting satisfaction. At the Battle of the Philippine Sea, Japanese fighters had destroyed 19 American carrier aircraft for the loss of 12 defending fighters. At Rabaul throughout 1943, Ki-61 Tony fighters had maintained a 3-1 kill ratio against P-38 Lightnings and F-4U Corsairs. Over Burma, Japanese pilots flying the legendary A-6M0 had consistently outmaneuvered British Hurricanes and American P-40s, achieving kill ratios that sometimes reached 7-1 in Japan's favor. The Ki-84 represented the culmination of this combat evolution, incorporating superior climb rate, heavier armament, and better high-altitude performance than any previous Japanese fighter. Japanese test pilots had pushed the aircraft to 41,000 feet in optimal conditions, a ceiling that American B-17s and B-24s could never hope to reach in combat configuration with full bomb loads. The Zero could sustain combat at 32,000 feet for up to 2 hours, while American bombers struggled to maintain operational altitude for more than 30 minutes at their maximum ceiling. Recent American failures reinforced Japanese confidence. In October 1944, American B-29s attempting raids from bases in China had suffered mechanical failures at a rate exceeding 30%. with numerous bombers forced to abort missions due to engine overheating at high altitude. 7 B-29s had crashed on takeoff or shortly after launch from Chinese airfields, killing 70 crewmen without Japanese fighters firing a single shot. American bombers attempting the difficult flight over the Himalayas, the infamous Hump Route, had lost 31 aircraft to weather, mechanical failure, and Japanese interception in 3 months. The B-29 program had experienced catastrophic test failures, including the death of Boeing's chief test pilot Eddie Allen when a prototype caught fire and crashed in Seattle in February 1943. These failures suggested that American ambition exceeded American capability, that their technological reach had outstripped their engineering grasp. Major Nakamura's combat record extended beyond simple kill tallies. He had survived the brutal fighting over Guadalcanal in 1942, where he had learned to exploit the Zero's superior maneuverability against heavier American fighters. He had mastered the art of diving attacks from superior altitude, using gravity and surprise to overcome any American advantage in armor or firepower. Nakamura had trained dozens of younger pilots in these proven tactics, drilling them repeatedly on the mathematics of interception, calculating closure rates, predicting bomber formations' defensive patterns, identifying the optimal angle of attack that minimized exposure to defensive gunfire while maximizing firing time on target. His techniques had been incorporated into Japanese fighter doctrine and taught at every training base from Formosa to the home islands. When intelligence reports described the B-29 as America's super weapon, Nakamura saw only another 4-engine bomber that would burn and fall like all the others. Lieutenant Colonel Watanabe had studied intelligence reports with growing unease throughout late 1944. He had compiled data on American industrial production that suggested a capacity vastly exceeding anything Japan could match. American factories were producing 70,000 aircraft annually compared to Japan's 17,000. American shipyards were launching a new aircraft carrier every month, while Japan struggled to replace losses from the Battle of the Philippine Sea. Watanabe had calculated that American aluminum production exceeded 900,000 tons annually, while Japan's entire output barely reached 140,000 tons, a ratio of more than 6-to-1 in America's favor. He had presented these figures to headquarters staff, carefully explaining that material advantage of this magnitude would eventually overwhelm any tactical superiority Japanese pilots achieved in individual combat. But his concerns were dismissed as defeatist thinking. "Numbers on paper don't win battles," Nakamura had told him curtly. "Our pilots do." The mathematics seemed irrefutable to Nakamura and most of the Imperial staff, but Watanabe feared they were calculating with incomplete data. Captain Tanaka represented the third critical witness to Japan's confident miscalculation. A combat pilot with 12 kills flying the Kai-61 Tony over New Guinea, Tanaka had personally experienced Japanese fighter superiority. In a battle over Wewak in August 1943, his 4-plane formation had intercepted 9 B-24 Liberators escorted by 6 P-38 Lightnings. The engagement lasted 11 minutes. Tanaka's formation destroyed 4 B-24s and damaged 3 others severely enough to force their withdrawal. 2 P-38s went down trailing smoke and fire. Japanese losses: 1 Kai-61 damaged but successfully recovered. Kill ratio: 6-0. Tanaka had watched American bombers explode when 20 cannon shells penetrated their fuel tanks. He had seen American fighters flee when Japanese pilots pressed attacks with suicidal determination. The Americans had armor and firepower, but Japanese pilots had courage and skill that turned mathematical disadvantages into combat victories. When intelligence described the B-29 as invulnerable at high altitude, Tanaka remembered watching supposedly invulnerable B-24s tumble from the sky over New Guinea. The mathematics seemed irrefutable. Superior Japanese pilots in superior Japanese fighters would destroy any bomber the Americans deployed. Seattle, Washington, January 1943. William Allen stood in the middle of Boeing's Plant 2 at 600 hours, watching the third B-29 fuselage of the morning shift roll past him on the assembly line. This single facility produced 17 major subassemblies daily, each representing thousands of individual components manufactured, inspected, tested, and integrated with mechanical precision that would have seemed impossible 3 years earlier. Every 6 hours, Another B-29 moved one full station closer to completion along the production line that stretched across 1.6 million square feet of factory floor. The plant operated 3 shifts covering 24 hours, never stopping, never slowing, producing bombers with an efficiency that transformed aviation from craftsmanship to mass production. In March 1942, America produced just 9 B-29s total, as Boeing struggled to transition from prototype to production, each aircraft requiring 175,000 man-hours to complete. By September 1942, production reached 14 B-29s monthly, as assembly line techniques began reducing manufacturing time to 97,000 man-hours per aircraft. By March 1943, Boeing's Seattle plant was producing 27 B-29s monthly, with man-hours reduced to 76,000 per aircraft. By September 1943, a single shift at Plant 2 could complete major assembly work on 3 B-29s simultaneously, with man-hours falling to 58,000 per aircraft. This single facility was producing more 4-engine bombers monthly than Japan's entire aviation industry, produced heavy bombers in a year across all manufacturers combined. Dorothy Williams, previously a high school mathematics teacher in Tacoma, now operated a riveting gun that drove 1,847 rivets per shift into B-29 wing sections. Each rivet had to meet precise specifications for depth, angle, and tension, with inspectors checking every 100th rivet and randomly sampling another 50 per shift. Williams completed her rivet quota with a defect rate below 0.3%, better than most male workers who had dominated aircraft manufacturing before the war. She produced more structural rivets in one 8-hour shift than the entire workforce at Japan's Nakajima plant in Oda produced in a full day across all aircraft types. Williams worked alongside 7 other women in her section, all of whom had transitioned from civilian occupations to precision manufacturing in less than 6 weeks of training. The mathematics were unambiguous. American factories were producing more combat aircraft in a month than Japan produced in 4 months, and the gap widened every quarter. James Washington, from Montgomery, Alabama, operated a hydraulic press that stamped aluminum sheeting into curved sections for B-29 engine cowlings. His press completed one cowling section every 12 minutes, working continuously, except for a 15-minute break every 4 hours. Washington's single station produced enough cowling sections daily to supply 17 B-29s. His output alone exceeded the entire daily production of engine cowlings at Japan's Mitsubishi plant in Nagoya, which manufactured components for Ki-67 heavy bombers at a rate of 2 aircraft weekly. Washington had worked in an automobile factory before the war, and he brought Detroit's mass production mentality to aircraft manufacturing, identifying efficiencies and suggesting improvements that plant managers implemented within days. The hydraulic press he operated represented $47,000 in capital investment, and Boeing had installed 340 identical presses across 3 plants. His single station's daily output exceeded Japan's entire monthly capacity for similar components. Henry Kaiser had left Kaiser Permanent to become a $1-a-year man, coordinating aluminum supply across the Western Defense Command. Kaiser managed the flow of raw aluminum from Alcoa's smelters in Washington and Oregon to Boeing's Seattle and Renton plants, ensuring that Boeing never waited more than 8 hours for critical materials. He had streamlined transportation by dedicating entire freight trains exclusively to aluminum shipment, cutting delivery time from 11 days to 4. Kaiser coordinated with the War Production Board to prioritize aluminum allocation, securing Boeing's access to 11,000 tons of aluminum monthly, while Japan's entire aviation industry received roughly 9,000 tons monthly from all sources combined. Kaiser's logistics network moved more raw materials in a week than Japan's entire supply chain moved in a month. The industrial capacity gap wasn't just production, it was everything. Raw materials, transportation, management, and coordination operating at scales that rendered comparison almost meaningless. Americans discarded 340 pounds of aluminum scrap daily at Boeing's Seattle plant, material that was collected and recycled, but represented waste from normal manufacturing tolerances. Japan allocated 127 pounds of aluminum monthly to each fighter squadron for repairs and maintenance. The waste from Boeing's quality control process exceeded Japan's operational allocation, by a factor of 3 to 1. American workers threw away aluminum pieces larger than what Japanese mechanics received for critical repairs. American manufacturing standards permitted waste that would be criminal negligence in resource-starved Japan. The mathematics were brutal. American excess exceeded Japanese necessity. The waste from Boeing's three-shift lunch program would have scandalized Japanese planners. Workers threw away 180 pounds of bread daily, bread that was too stale to meet cafeteria standards, but perfectly edible by any rational measure. Japanese infantry units in Burma received 22 pounds of bread weekly for entire platoons of 40 men. The cafeteria discarded more protein in chicken and beef trimmings daily than Japanese bomber crews received monthly in their entire meat ration. Boeing's Plant 2 cafeteria staff disposed of 420 pounds of food waste daily, organic material that went to pig farms for animal feed rather than feeding humans. Japanese soldiers in the Philippines were starving on 900 calories daily, while Americans threw away thousands of calories as substandard. Workers at Boeing's Renton plant discarded rubber gaskets that failed dimensional inspection, throwing away 67 pounds of rubber daily. Japan allocated 8 pounds of rubber monthly to fighter maintenance crews responsible for 20 aircraft. The rubber waste from quality control at a single American plant exceeded Japan's allocation to an entire air group. Japanese pilots flew missions with worn gaskets and failing seals because replacement parts didn't exist, while Americans threw away components for being 3 millimeters out of specification. The waste that American inspectors rejected would have been treasured components in Japanese maintenance depots. American machine shops produced metal shavings and turnings that collected in bins and were melted down for reprocessing. Boeing's Seattle plant generated 11,000 pounds of steel shavings weekly from machine operations, material that was recycled but represented the waste byproduct of manufacturing precision components. Japan's entire steel allocation to the aviation industry barely exceeded 2,000 tons monthly, and every gram was precious. The metal shavings from American quality manufacturing exceeded the raw material that Japanese engineers received for entire aircraft. Americans could afford waste because their production capacity was effectively unlimited compared to Japan's starvation economy. The aluminum, rubber, steel, and food that Americans discarded in normal operations could have built and maintained Japan's entire fighter force for a month. This single waste stream from 3 Boeing plants represented more material resources than Japan allocated to home defense. American workers threw away what Japanese soldiers would have killed to possess. The mathematics were devastating before a single shot was fired in anger. America could waste more than Japan could produce. Lieutenant Colonel Watanabe visited Boeing's Seattle plant in July 1943 as part of a neutral diplomatic delegation before war made such visits impossible. He had watched assembly lines with growing horror, counting aircraft in various stages of completion and calculating production rates that exceeded his worst intelligence estimates. Watanabe had reported to Tokyo that American production capacity represented an existential threat that tactics and courage could not overcome. His report was filed and largely ignored. Japanese commanders believed that American industrial capacity was irrelevant if Japanese fighters could destroy American bombers faster than factories could replace them. Watanabe knew the mathematics told a different story. America could lose 5 aircraft for every Japanese loss and still expand their fleet while Japan contracted. But his warnings were dismissed as defeatist, his calculations rejected as enemy propaganda. The mathematics were irrefutable, but Japanese commanders refused to believe them. November 24, 1944, Tokyo, Japan, 13:47 hours. Captain Tanaka was conducting a routine patrol at 27,000 feet over Tokyo Bay when his wingman's voice cracked over the radio. Formation at 3 o'clock high, distance 15 kilometers. Tanaka turned his head and saw them, 9 silver crosses catching sunlight against the dark blue sky at impossible altitude. The bombers were flying at 32,000 feet, higher than any American bomber had previously operated over Japan, their contrails streaming white against the stratosphere. At 13:49 hours, Tanaka pushed his Ki-84 throttle forward and pulled back on the stick, beginning a climb to intercept. At 13:53 hours, his altimeter passed 30,000 feet, and his rate of climb began deteriorating as the thin air reduced engine performance and control surface effectiveness. At 13:56 hours, Tanaka reached 31,500 feet, approximately 500 feet below the bomber formation's altitude. His airspeed had dropped to 190 miles per hour, barely above stall speed, and his controls felt mushy and unresponsive. He could see the bombers clearly now, sleek silver giants with high-mounted tails and wings that seemed impossibly large. Tanaka lined up on the nearest bomber and pressed the trigger. His 20mm cannons barked, and he watched tracer rounds arc upward toward the target, then fall away short as gravity and air resistance killed their momentum. The rounds fell 200 feet below their target. At 13:58 hours, Tanaka tried again, climbing another 100 feet through sheer determination and firing another burst. The rounds again fell short. The B-29 serenely continued on course, completely untroubled by his attack. At 14:01 hours, Tanaka watched in disbelief as all 9 B-29s began climbing, their noses tilting upward as they ascended to 33,000 feet, then 34,000 feet, rising above his Ki-84 absolute ceiling with effortless power. His fighter could not follow. The mathematics of altitude and engine performance had betrayed him. Tanaka's Ki-84 could theoretically reach 38,000 feet in test conditions with minimal fuel and no ammunition. But at combat weight with full fuel and weapons, 32,000 feet represented his effective ceiling. The B-29s could cruise at 35,000 feet loaded with 10 tons of bombs, and they had just demonstrated that they could climb higher still if threatened. At 14:03 hours, Tanaka radioed headquarters. Enemy bombers operating at altitudes exceeding our interception capability. Request orders. The response took 3 minutes. At 14:06 hours, headquarters ordered him to break off and return to base. Elapsed time from first contact to disengagement, 17 minutes. Enemy aircraft damaged, 0. Enemy aircraft destroyed, 0. Japanese losses, 0 aircraft, but something more important was destroyed in those 17 minutes, the assumption of Japanese air superiority. Total engagement duration, 17 minutes, 0 seconds. Enemy losses, 0 aircraft, 0 pilots. American losses, 0. Kill ratio, 0-0, but the strategic implications were devastating. The ammunition expended in this 17-minute engagement exceeded Japan's monthly allocation for routine training across the entire Tokyo defense sector. Tanaka had fired 140 rounds of 20 ammunition and 380 rounds of 12.7 ammunition without scoring a single hit. The fuel consumed climbing to intercept altitude exceeded what his squadron received for a week of defensive patrols. The B-29s had forced Japan to expend irreplaceable resources just to reach their altitude, and then they had climbed away untouched, unreachable, invulnerable. Captain Tanaka landed at 14:34 hours and immediately reported to Major Nakamura. "Sir, the bombers operated at altitudes we cannot effectively reach. My Ki-84 could not climb high enough to engage successfully. When I did reach their altitude, I was too slow to maneuver, and my weapons fell short." Nakamura reviewed the combat report with visible frustration. "You reached 31,500 feet. The specifications say your aircraft can reach 38,000 feet. Why did you fail to reach operational altitude?" Tanaka struggled to maintain professional calm. "Sir, the specifications reflect test conditions. In combat configuration with full ammunition and fuel, the Ki-84 ceiling is at least 6,000 feet lower. The Americans are operating at altitudes we physically cannot reach." Nakamura dismissed the report as pilot error, as insufficient aggression, as everything except what it actually represented: technological and industrial superiority that rendered Japanese tactics obsolete. "The Ki-84 is superior to anything the Americans fly," Nakamura insisted, his voice rising. "The problem is not the aircraft, it's the pilot's execution. Tomorrow you will intercept successfully." But Tanaka knew the mathematics had shifted. The B-29 could fly higher, faster, and farther than any Japanese fighter could reach at combat weight. American bombers had escaped the physics that constrained Japanese interceptors. The confident assumptions that had filled the headquarters conference room 3 weeks earlier were evaporating in the thin air above Tokyo. Intelligence dismissed the reports as exaggerated, as the predictable excuses of pilots who had failed to engage effectively. Major Nakamura reviewed 3 separate engagement reports from different squadrons, each describing the same scenario: Japanese fighters climbing to intercept, reaching altitudes that left them barely controllable, firing weapons that fell short, and watching helplessly as B-29s climbed away to safety. The reports described an impossible aircraft that defied everything Japanese engineers understood about high-altitude performance. Bombers this large cannot operate effectively at 35,000 feet, Nakamura declared at the evening briefing. The physics do not allow it. These reports represent pilot error, equipment failure, or enemy deception, but they cannot represent the actual performance of a four-engine bomber at maximum combat weight. Lieutenant Colonel Watanabe reported to headquarters the following morning with detailed analysis of the B-29's actual performance compared to intelligence estimates. Sir, we calculated their ceiling at 35,000 feet based on European bomber performance. The Americans have developed supercharged engines that maintain power at altitudes where our fighters lose effectiveness. Their bomber weighs 60 tons fully loaded and can still climb to 37,000 feet. A single B-29 carries more bomb load than 6 Ki-67s combined. Watanabe presented production comparisons that he had compiled from multiple intelligence sources. American production, 120 B-29s monthly as of October. Japanese heavy bomber production, 7 Ki-67s monthly across all factories. A single American facility exceeds our entire heavy bomber industry by a ratio of 17-1. American production of fighter aircraft reached 5,100 units monthly by late 1944, compared to Japan's 1,200 fighters monthly from all sources. A single American factory, Republic Aviation's Farmingdale plant, produced 432 P-47 Thunderbolts monthly, exceeding the combined output of Japan's 3 largest fighter plants. American engine production reached 7,300 aircraft engines monthly, while Japan struggled to produce 1,900 engines from all manufacturers. American aluminum production totaled 920,000 tons annually compared to Japan's 141,000 tons, a ratio of 6.5-1. A single American aluminum smelter, Alcoa's plant in Vancouver, Washington, exceeded Japan's entire aluminum production capacity. The mathematics were catastrophic. America could outproduce Japan across every category of material, and the gap was widening monthly. Japanese commanders tried ramming attacks, with fighters deliberately colliding with B-29s to destroy them. The Americans reinforced their bombers' structure and continued operations. Japanese pilots attempted diving attacks from above, but the B-29's speed at altitude meant that Japanese fighters had only seconds of firing time before overshooting their target. They attempted head-on attacks, but the B-29's forward armament of 2.50 caliber machine guns in the nose turret and 2 more in the upper forward turret created a devastating defensive fire zone. Japanese fighters trying coordinated attacks from multiple angles found that B-29s flew in formation with overlapping defensive fire that created kill zones no fighter could penetrate safely. Every tactic that had worked against B-17s and B-24s failed against the B-29's combination of altitude, speed, armament, and structural strength. On December 3, 1944, 70 B-29s bombed Tokyo with impunity, operating at altitudes where Japanese interceptors could barely reach them and could not maneuver effectively. Japanese fighters launched 247 sorties attempting to intercept the raid. Total engagement duration, 43 minutes. Enemy losses, 1 B-29 damaged by anti-aircraft fire, 0 losses to fighter action. Japanese losses, 9 fighters destroyed, 14 pilots dead including 2 from crashes while attempting to reach intercept altitude. Kill ratio, 70 B-29s completed their mission versus 9 Japanese fighters destroyed by accident or desperation. Elapsed time for American bombers from entry to Japanese airspace to departure, 91 minutes. 0 American casualties from Japanese fighters. The ammunition expended by Japanese fighters attempting to intercept this raid exceeded 2 weeks' allocation for gunnery training across the entire Tokyo defense sector. Fighters fired approximately 14,000 rounds of 20 ammunition and 47,000 rounds of machine gun ammunition, scoring perhaps 30 hits total on bomber formations that barely noticed the damage. The fuel consumed by 247 sorties exceeded what Japan allocated to fighter defense for 3 days of operations. Japanese fighters were burning irreplaceable aviation gasoline to reach altitudes where they could not fight effectively, firing irreplaceable ammunition that could not reach its targets, and losing irreplaceable pilots without inflicting significant damage on American bombers. The mathematics of attrition had reversed. Japan was losing resources faster than America was losing aircraft, and America could replace losses while Japan could not. Lieutenant Colonel Watanabe presented his final assessment on December 5, 1944. The B-29 represents a technological leap we cannot counter with existing equipment. American industrial production has created quantitative superiority that our qualitative advantages cannot overcome. We are losing pilots at a rate of 40 monthly to B-29 operations. We are training new pilots at a rate of 23 monthly. The mathematics project total pilot attrition within 7 months. Headquarters staff listened in uncomfortable silence. The confident assumptions of November had collided with December's brutal reality, but Major Nakamura still refused to accept the implications. "We will develop new tactics," he insisted. "We will train pilots to intercept at higher altitudes. We will modify our fighters to increase ceiling. We will adapt and overcome." Watanabe said nothing. The mathematics were irrefutable, but commanders who had built careers on Japanese superiority could not accept them. Captain Tanaka observed the escalation with growing despair. On December 13, he flew his 5th interception sortie against B-29 formations. He reached 31,800 feet and fired a long burst at a bomber 300 feet above him. Every round fell short. The bomber's tail gunner returned fire, and a .50 caliber round punched through Tanaka's canopy 3 inches from his head. He broke off and dove away, his aircraft shuddering as airspeed built. Lapse time at intercept altitude, 47 seconds. Rounds fired, 190. Hits scored, 0. His fighter had consumed fuel that would have supported 2 normal combat patrols just to reach an altitude where he was nearly helpless, and he had accomplished nothing except nearly dying. The mathematics had become personal. Japanese fighters were sacrificing everything to reach altitudes where they could barely function while American bombers operated with casual efficiency. At Boeing's Renton plant, production workers achieved new efficiency records weekly throughout late 1944 and early 1945. Every 48 hours, another B-29 rolled off the assembly line complete and ready for delivery to the Army Air Force. This single facility produced more than Japan's entire heavy bomber industry. Boeing's 3 main plants, Seattle, Renton, and Wichita, collectively produced 327 B-29s monthly by January 1945, exceeding Japan's total aircraft production across all categories. The waste from Boeing's quality control procedures could have built a significant percentage of Japan's aircraft production if Japan had possessed the materials, tools, and skilled labor to utilize the discarded components, which they did not. Americans discarded 540 pounds of aluminum daily at Renton due to dimensional tolerance failures, components that were too far out of specification for American standards, but would have been treasured parts in Japanese factories. Japan allocated 410 pounds of aluminum weekly to fighter squadrons for repairs and modifications, less than what Boeing threw away daily at a single plant. American manufacturing standards permitted waste that Japanese engineers would have considered criminal negligence. Workers threw away ball bearings that failed smoothness tests, discarding components that Japanese mechanics reused until they literally fell apart. The quality control reject rate at American plants exceeded Japan's production rate for similar components. The Renton plant cafeteria discarded 680 pounds of food daily, material that didn't meet freshness standards or represented overproduction from meal service. Japanese bomber crews received 2,100 calories daily from their food allocation, much of it rice supplemented with small amounts of fish or vegetables. The cafeteria waste from Boeing's single plant exceeded the food allocation for a Japanese bomber squadron of 120 men. Americans threw away bread, meat, vegetables, and fruit that would have represented luxury rations for Japanese combat personnel. The mathematics of abundance versus scarcity played out in every aspect of production. Americans could waste more than Japan could produce. Aluminum scrap from a single day of operations at Boeing plants exceeded 3,400 pounds, material collected for recycling, but representing the waste stream from normal manufacturing. Japan's monthly aluminum allocation to the entire aviation industry barely exceeded 9,000 tons, with perhaps 240 pounds allocated daily to individual fighter squadrons. The scrap rate from American quality manufacturing exceeded Japan's operational allocation by factors of 10 or more. Americans could afford to maintain standards that rejected components for minor defects, because their production volume was effectively unlimited. Japanese engineers accepted components with significant defects because alternatives didn't exist. American ammunition testing procedures consumed rounds that Japanese squadrons would have treasured for combat operations. Boeing tested defensive armament by firing 10,000 rounds per bomber to verify gun function and ammunition feed reliability. These test firings consumed more .50 caliber ammunition than a Japanese fighter squadron received monthly for combat operations. Americans fired ammunition to ensure quality, while Japanese pilots rationed every round for maximum effect. The testing and quality control procedures that ensured American equipment reliability consumed resources that represented Japanese operational allocations. Americans could afford perfection because they produced at scales that made individual unit costs nearly irrelevant. Every waste stream from American production exceeded Japanese operational capacity. The metal shavings from machine operations could have been melted down into Japanese manufacturing feedstock. The food waste could have fed Japanese bomber crews for weeks. The discarded components could have kept Japanese fighters flying. But Japan lacked the transportation capacity to move material from America to Japan, lacked the industrial capacity to process the materials even if they could obtain them, and lacked the skilled workforce to manufacture components even if raw materials were available. The mathematics were suffocating. America possessed such overwhelming industrial superiority that their waste streams exceeded Japan's production capacity. Lieutenant Colonel Watanabe compiled his most comprehensive production analysis in January 1945, documenting the industrial gap with brutal precision. American production of B-29s, 327 monthly. Japanese production of all heavy bombers combined, 9 monthly. American fighter production, 5,400 monthly. Japanese fighter production, 1,340 monthly. American pilot training capacity, 6,700 pilots monthly. Japanese pilot training capacity, 410 pilots monthly. American fuel production, 5.7 million barrels of aviation gasoline monthly. Japanese fuel production, 340,000 barrels monthly. Every comparison favors America by ratios between 3:1 and 30:1. This single aircraft, the B-29, represents American industrial capacity that we cannot match or counter. Watanabe presented his report to headquarters staff, who received it in grim silence. The confident assertions of November had died in December's frozen skies above Tokyo. On March 9, 1945, 334 B-29s attacked Tokyo in a firebombing raid that killed approximately 100,000 civilians and destroyed 16 square miles of the city. Japanese fighters launched 167 sorties attempting to intercept the attacking bombers. The engagement lasted from 8 hours to 12 hours, 3 hours and 4 minutes of sustained combat over Tokyo. At 8 hours, the first B-29s entered Japanese airspace at 29,000 feet. At 12 hours, Japanese fighters began climbing to intercept altitude. At 29 hours, first contact occurred between defending fighters and attacking bombers. At 29 hours, 6 Ki-84 fighters engaged the lead B-29 formation. At 32 hours, one B-29 sustained damage to its number 3 engine and fell out of formation. At 33 hours, Japanese fighters pressed their attack, closing to within 200 yards. At 33 hours and 40 seconds, defensive fire from the B-29 formation destroyed one Ki-84. Elapsed time from engagement to destruction, 4 seconds. Kill time, 4 seconds. At 34 hours, a second Ki-84 collided with a B-29's tail section in a deliberate ramming attack. Both aircraft plunged toward the ground. Elapsed time from engagement to mutual destruction, 5 seconds. 2 aircraft destroyed, 1 B-29 and 1 Ki-84 mutual kill. At 47 hours, a formation of 8 N-1K-2, George, fighters engaged B-29s bombing from 24,000 feet. At 49 hours, coordinated attacks from multiple angles damaged 2 B-29s. At 50 hours, one damaged B-29 fell out of formation and descended to 18,000 feet. At 51 hours, 4 N-1K-2 fighters pursued the damaged bomber. At 53 hours, concentrated fire ignited the B-29's fuel tanks. At 53 hours and 37 seconds, the bomber exploded. Elapsed time from engagement to destruction, 6 minutes 37 seconds. Kill time, 6 minutes 37 seconds. At 54 hours, the surviving N-1K2 fighters climbed to re-engage the main formation. At 56 hours, defensive fire destroyed 2 N-1K2 fighters in rapid succession. First kill time, 3 seconds. Second kill time, 5 seconds. At 1:12 hours, Major Yoshio Nakamura led a formation of 6 Ki-84 fighters, climbing through 26,000 feet toward incoming B-29s. At 1:14 hours, Nakamura's formation engaged B-29s bombing from 27,000 feet, a lower altitude than previous raids. At 1:16 hours, Nakamura closed to 150 yards on a B-29's port quarter and opened fire. His 20 rounds struck the bomber's wing and fuselage, but the B-29 maintained formation. At 1:17 hours, Nakamura pressed his attack, closing to 100 yards. The B-29's defensive fire intensified. At 1:17 hours and 43 seconds, .50 caliber round penetrated Nakamura's engine, and glycol coolant sprayed across his windscreen. At 1:17 hours and 51 seconds, his engine seized and his propeller froze. At 1:18 hours and 7 seconds, Nakamura's Ki-84 entered an uncontrolled spin. Elapsed time from engagement to death, 2 minutes 7 seconds. Kill time, 2 minutes 7 seconds. The engagement over Tokyo on March 9-10, 1945, lasted 3 hours and 4 minutes. Enemy aircraft destroyed. 14 B-29s, 12 to fighter action and 2 to anti-aircraft fire. American losses included 154 crewmen killed or captured. Japanese losses: 42 fighters destroyed, 61 pilots dead including Major Yoshio Nakamura, squadron commander and holder of 17 confirmed kills. Kill ratio: 14 to 42, a ratio of 3 to 1 in America's favor. The ammunition expended by Japanese fighters exceeded 6 weeks' allocation for the entire Tokyo defense sector. The fuel consumed exceeded 10 days' operational allocation. The pilots lost represented 18 months of training capacity that Japan could no longer provide. An unnamed Japanese pilot, captured after bailing out of his destroyed Ki-84 during the March 9 raid, was interviewed by American intelligence officers on March 14, 1945. His testimony was recorded. "This wasn't combat. This was systematic annihilation. Your bombers flew in perfect formation despite our attacks. Your defensive fire destroyed our fighters before we could close to effective range. We killed some of your aircraft, but you killed 3 of us for everyone we destroyed, and you had more aircraft to lose. Every night we launched knowing we probably wouldn't return. Every night more of us died. Every night your bombers came back in greater numbers. You were grinding us into dust with mathematics we couldn't counter." The testimony continued for 2 hours, documenting the psychological destruction of facing industrial superiority that turned courage into suicide. By April 1945, Japanese fighter squadrons defending the home islands had lost 60% of their pilots and 72% of their aircraft to B-29 operations and related combat. Replacement pilots arrived with perhaps 40 hours of flight training compared to the 200-plus hours that Japanese pilots had received in 1942. These undertrained pilots died at horrifying rates, sometimes lasting only 2 or 3 sorties before being shot down. Japan's aviation fuel allocation had dropped to 40% of the already inadequate levels from December 1944, forcing commanders to choose between training new pilots and flying combat missions. The choice was false. Insufficient fuel meant pilots arrived at combat squadrons with barely enough experience to take off and land safely, let alone engage elite American bomber crews flying aircraft with overwhelming technological advantages. The mathematics of attrition had become a death spiral. Japan needed 380 new pilots monthly to replace losses, but could train only 210 monthly with available fuel and instructors. Japan needed 840 new fighters monthly to replace losses, but could manufacture only 520 monthly with available materials and industrial capacity. America was producing 1,200 B-29s quarterly by early 1945, expanding their bomber fleet even while losing aircraft to combat and accidents. America was training 4,100 bomber crew members monthly, providing replacements and expansion capacity simultaneously. The industrial and training gap had widened to ratios exceeding 10 to 1 in most categories, and the gap continued expanding because America could allocate unlimited resources to aviation, while Japan scraped the bottom of its resource barrel. Lieutenant Colonel Saburo Watanabe survived the war and testified at multiple post-war conferences about Japan's strategic miscalculations. His testimony in September 1945, delivered to American strategic bombing survey teams, represented perhaps the most comprehensive analysis of how industrial capacity determined the Pacific Air War's outcome. We were not defeated by better soldiers, but by better factories. American production of B-29s totaled 3,970 aircraft from 1943 through 1945. Japan's production of all heavy bombers from 1943 through 1945 totaled 91 aircraft across all types. A single American factory, Boeing's Renton plant, produced more four-engine bombers than our entire industry. We couldn't replace losses because we lacked aluminum, lacked engines, lacked skilled workers, lacked tools, lacked everything except courage, and courage alone cannot build aircraft. You produced 58,000 fighter aircraft from 1943 through 1945. We produced 19,000. You lost 16,000 aircraft and still expanded your force. We lost 11,000 aircraft and faced extinction. The mathematics were inescapable. You could afford to lose 2 aircraft for everyone we lost and still overwhelm us through numerical superiority. But in reality, we lost 3 aircraft for everyone you lost by 1945, making the disparity even more crushing. Watanabe's testimony continued with brutal honesty. We calculated that our superior pilots and superior fighters would destroy your bombers faster than you could replace them. We were wrong about pilot quality, aircraft quality, and production capacity simultaneously. Your B-29 flew higher than our fighters could effectively reach. Your defensive armament created kill zones our tactics couldn't penetrate. Your armor prevented our weapons from inflicting critical damage. And you produced these superior aircraft at rates we couldn't comprehend. We brought swords to industrial warfare, bringing craftsmanship to face mass production, bringing limited resources to face unlimited capacity. Captain Hiroshi Tanaka, who survived the war with 24 confirmed kills, but also 14 aircraft lost beneath him, testified in October 1945. I saw firsthand what industrial superiority meant in combat. On November 24, 1944, I watched B-29s climb away from my Ki-84 as if I were standing still, mocking our fighters' specifications with actual performance that exceeded what we thought possible. Your bombers shouldn't have been able to fly at those altitudes with those bomb loads at those speeds, but they did because you revolutionized production itself. You didn't just build aircraft, you built entire industries that built aircraft. You created workers who built tools that built components that built bombers. We were fighting your factories, and your factories were winning. Additional testimonies from captured pilots and post-war interviews revealed the psychological impact of facing overwhelming industrial capacity. We were fighting mathematics, not men, one pilot stated. Every night we launched knowing the Americans had more bombers than we had fighters, more fuel than we needed for a year, more ammunition than we could fire in a month. They could lose half their force and return the next night with more aircraft than they started with. We lost 2 fighters and couldn't replace them for a week. The mathematics destroyed morale before the combat did. Their excess capacity exceeded our maximum effort, testified a Japanese aviation engineer. They built 3,970 B-29s, and that represented perhaps 30% of their 4-engine aircraft production. They built more B-24s than we built aircraft of all types. They produced more engines in a month than we produced annually. They trained more pilots monthly than our entire fighter force contained. They could afford to waste more aluminum than we received as our total allocation. The comparison wasn't just unfavorable, it was obscene. They could lose 300 B-29s and replace them in 6 weeks, another pilot testified. We lost 300 fighters and needed 4 months to replace them if we had the materials, which we usually didn't. They operated from bases in the Marianas with unlimited fuel, unlimited bombs, unlimited spare parts, unlimited everything. We rationed fuel by the liter, ammunition by the round, spare parts by individual components. We cannibalized aircraft to keep others flying. They threw away parts that would have kept our entire squadron operational. The mathematics were devastating before combat even started. We discussed tactics endlessly, trying to find approaches that would let us kill B-29s without dying ourselves, testified a surviving squadron commander. We tried head-on attacks, Tail attacks, diving attacks, climbing attacks, ramming attacks, coordinated multiplane attacks, everything we could imagine. Some tactics worked occasionally, but the Americans adapted faster than we could innovate. They added more armor, more guns, more countermeasures. And the fundamental mathematics never changed. They had more aircraft than we had ammunition to shoot them down, even if every round we fired destroyed a bomber, which obviously didn't happen. We were fighting arithmetic that couldn't be overcome with courage. Production statistics compiled by post-war analysts revealed the true scale of American industrial dominance. American production of B-29s totaled 3,970 aircraft. Japanese production of Ki-67 heavy bombers, their closest equivalent, totaled 698 aircraft. Single American factories exceeded Japan's entire heavy bomber production. Boeing's Renton plant, 1,119 B-29s. Japan's entire heavy bomber production across all manufacturers, 698 Ki-67s plus approximately 130 other heavy bomber types. American aluminum production, 2.8 million tons during wartime. Japanese aluminum production, 421,000 tons during wartime. American aviation gasoline production, 384 million barrels during wartime. Japanese aviation fuel production, 14 million barrels during wartime, a ratio of 27-1. The B-29 proved that democratic nations at war possess industrial advantages that authoritarian regimes cannot match. Free workers outproduced slaves and conscripts because motivation, innovation, and initiative flourish in freedom. Democratic cooperation exceeded totalitarian command because decentralized decision-making solved problems faster than hierarchical approval systems. Industrial abundance buried ideological superiority under millions of tons of aluminum, steel, rubber, and explosives, shaped into aircraft that dictated the war's outcome through mathematical inevitability rather than tactical brilliance. The B-29 demonstrated that wars between industrial powers are won in factories and decided by production capacity long before combat determines outcomes. Strategic planners dismiss material factors at their civilization's peril. Japan's military excellence, tactical innovation, and warrior courage could not overcome a 15-1 deficit in aluminum production, a 27-1 deficit in fuel production, and a 3-1 deficit in overall aircraft production. Superior training and superior courage bought time, inflicted casualties, and won individual battles, but arithmetic ultimately determined the war's outcome with mathematical certainty that no amount of fighting spirit could alter. November 24, 1944, Major Yoshio Nakamura had laughed at the B-29, dismissing American innovation as irrelevant against Japanese fighter superiority. March 10, 1945, Nakamura died in a burning Ki-84, shot down by the defensive armament of bombers he claimed couldn't threaten Japan. His mockery became history's most devastating miscalculation, measured in millions of Japanese dead and 2 cities destroyed by atomic weapons delivered by the very bombers he dismissed. Nakamura had calculated based on combat performance, ignoring production capacity. He understood tactics but not economics. He mastered fighting but not mathematics. His confidence died with him in the skies above Tokyo, one more victim of industrial warfare's brutal arithmetic. Lieutenant Colonel Watanabe's warnings in November 1944 had been dismissed as defeatism. By September 1945, they appeared as prophecy. He had calculated the true threat, while others calculated kill ratios. He understood that free people's productive capacity would overwhelm authoritarian discipline. He recognized that America's industrial revolution had created capacity that rendered traditional military thinking obsolete. His warnings were ignored until B-29s proved them correct, by which time millions had died learning lessons that mathematics had taught before the first bomb fell. The lesson remains urgent in any era when authoritarian regimes dismiss democratic nations as weak because they prefer peace, or underestimate free people's capacity to mobilize for total war when threatened. Dismissing democracies as decadent or assuming that authoritarian control provides military advantages invites catastrophic miscalculation. The B-29 demonstrated that free societies at war possess advantages that dictatorship cannot match: innovation without permission, production without coercion, coordination without command, and determination that comes from defending chosen values rather than obeying imposed ideology. The mathematics of November 1944 predicted the outcomes of August 1945 with perfect accuracy for anyone willing to calculate honestly. Japan's leaders refused to believe the arithmetic until B-29s made it undeniable, transforming mathematical certainty into mushroom clouds above Hiroshima and Nagasaki.